Hello friends, now we will discuss the next topic of BJT, that is common collector configuration. That is the last configuration of BJT. In common collector configuration, we connect input on the base side, but output is taken from the emitter terminal rather than the collector terminal. Although it appears that common is not emitter, common is not collector, but emitter itself, it's not like that. If you draw the circuit like this, it's connected here, and this VCC is connected just for DC biasing to establish the operating point. But as far as amplifier application is concerned, this configuration where you collect just biasing voltage at the collector and you take output from the emitter terminal, load is connected in series with the emitter, that configuration is called common collector configuration. Fine. When output is being taken from emitter terminal, emitter side. Fine. So here this configuration is not very commonly used for amplifier application, but there are certain advantages of this application. What are those advantages? Let us see that. What is V0? If you take this as the input voltage Vi, so V0 is equal to Vi, that is V input, minus nothing but VBE. Fine. This as from here to here, this input voltage. So V0 is approximately equal to, I'll say, V in case of common collector configuration. What is the advantage of that? If output voltage is approximately same as input, it is, although it is not same, but it is minus VBE. Fine. So what will be the voltage gain? Voltage gain approximately is V0 upon V in minus VBE. Fine. It is hardly 0.7 volt and it is approximately equal to 1. That's what I am saying. A common collector configuration has a voltage gain approximately equal to unity, but it is not a unity, it is less than unity, maybe of order of 0.9. So what is the advantage then? Its current gain is high. If its current gain is high, try to recall the pulse and digital circuits. Suppose I have a digital circuit. In digital circuits, what do we have? We have only one voltage level. So there is one signal having voltage level of 5 volt. I want to increase its power level without changing the voltage level. Voltage level in pulse and digital circuits has to be either 0 volt or 1 volt, or 1, you can logical 1, maybe 5 volt. So I want to increase power of a digital circuit, digital signal, without changing its voltage level. So I will connect an amplifier, or I will give that signal to an amplifier whose voltage gain is unity but current gain is high. So that will increase the power level of the digital signal without changing the voltage level. And common collector configuration is such configuration which does not change the voltage level. Output voltage and input voltage are same, but enhances the current level. Such type of amplifier is called buffer amplifier. So common collector configuration is most commonly used buffer amplifier to raise the power level of digital signals. So it has got applications there. So I repeat, some points to be remembered here. What are those points? The common collector configuration has voltage gain of order of unity, but its current gain is high. It is used as a buffer amplifier in pulse and digital circuits. It increases the power level without changing the type of configuration where emitter terminal is following the input voltage is called emitter follower. Emitter follower means the emitter terminal is following the input voltage. So this configuration is also known as emitter follower. Common collector configuration is also known as emitter follower. Fine. So this is the only application of this configuration. We won't be talking about input characteristics, output characteristics, and blah and blah. those things will not be talked about here. The only point is this amplifier is basically the unity voltage gain amplifier, having which is increasing the power level, having high current gain, which provides the power gain without changing the voltage level. It is used as a buffer amplifier, and so on. These are some of the points you should remember about common collector configuration. There are some points to be remembered. I will be comparing all the configurations here. So let us talk about the configurations one by one. I'll be comparing all the configuration in tabular form now. This table is very important. You have a lot of questions from this table, especially in engineering services, but there can be questions in GATE as well. So I'll be taking three configurations: common base, common emitter, common collector. I'll be talking about input resistance, fine, then output resistance, fine, then voltage gain, then current gain, then next point, phase shift between input and output, then leakage current. These are points I will be talking about. This is the first point, this is second point, this is third point, this is fourth point, this is fifth point, this is sixth point. I repeat, you have plenty of questions in engineering services prelims from this table itself, and there can be question this year also. There are questions in GATE as well, 1 mark question. Input resistance of common base configuration is low. This is high. This is high. Output resistance of this configuration is high. This is medium. This is low. Voltage gain of this configuration is high. This is high. Voltage gain of this is unity, you can say, low or unity. Current gain of this configuration is unity, but it's not unity, remember, of order of how much? 0.9 volt. It means it is less than unity. Please do remember this point. Unity means it is not exactly unity, but less than unity, maybe 0.09. I'm just giving you the range so that you remember. Then it's high. So your common emitter configuration has got high voltage gain and high current gain. Its current gain is high. Please remember all these points because there are a lot of questions on this table. Phase shift is 0 degree here. There is no phase shift between input and output signals. It is 180 degree. That is why it is used as an inverter. Common configuration is used as an inverter in pulse and digital circuits. Input signal will be shifted by 180 degree when it reaches at the output. This is 0 degree. There is no phase shift between input and output signals. Leakage current here is low. It is high. Here very high. Now applications. 7th, applications. Please do remember for engineering services point of view. It is used at radio. I need to check this point, please. Your common emitter configuration is used at audio frequency. So this is used at radio frequency. Used applications. Used as radio frequency amplifier. Fine. It is used as audio frequency, means low frequency amplifier. Please do remember this. And it is used as what? Used as buffer amplifier. I told what is buffer amplifier. That is amplifier which increases the power level without changing the voltage level. There are 7 points. Please do remember all the 7 points. There are plenty of questions from this table in engineering services prelims exam. From this table itself, I repeat, please remember all the points. This is very important table. So there are 2 more topics which are to be discussed from this here, that is Abers-Moll model, and then I'll be talking about switching characteristics of BJT. But till then, just go on revising and wait for my next video to come. Thank you for watching.